This is the second part of the video on writing equations for lines. In the previous one, we had taken a point and slope and used y equals mx plus b form to write the equation for the line. In this one, we're going to figure out what happens if we're only given 2 points and we have to write the equation of the line. So in this case, if you take a look at the first one, we're looking at the points 2, 14 and 4, negative 4. If you want to get a quick idea as to what these points look like on the coordinate plane, 2, 14 is way up here, and 4, negative 4 is down there. So we're going to try to write the equation for the line that connects those 2 points. Well, we need 2 things for a line. We need a point and we need slope. We have 2 points to choose from, so we're okay there. What we don't have is a slope. So the first thing we'll do is we'll try to find the slope between 2, 14 and the other point is 4, negative 4. All right, so slope is change in y over change in x. So I'm going to do my change in y as 14 minus negative 4. And then my change in x will be 2 minus 4. So remember, 2 negatives make a positive. 14 minus a negative 4 is 18. 2 minus 4 is negative 2. 18 divided by negative 2 is negative 9. So we knew that we were going to have a line that had a pretty steep negative slope. So making a rough sketch sort of confirms that that slope of negative 9 is a reasonable slope. All right, then I'm going to take my y equals mx plus b. And I'm going to fill in something for everything except that b. That b is what I'm trying to solve for because I don't know what the y-intercept is. Come over here to one of the 2 points. Maybe you want to pick the first one because they're both positive. Maybe you want to pick the second one because the numbers are smaller. Really, it doesn't matter. I'll pick 2 and 14 as my x and y. So I'm going to put the 14 in for y. I'm going to put that negative 9 in for m, right? Because I found the negative 9 when I calculated the slope. And then I'll put the 2 in for x. And I've got it. I've got something in there for everything except for that b. Right. Work through the couple of steps to solve for b. Negative 9 times 2 is negative 18. And then add 18 to both sides. 14 plus 18 is a big number, right? It's 32. If you look at my graph up here, the y-intercept is way up, probably off of my screen somewhere, which makes sense then that that y-intercept would be pretty big. So when I come over here to write my final answer, I start with y equals mx plus b. I need a y and an x in my equation, so I'm going to leave the y and leave the x. What is my slope? My slope is up right above that m. It's negative 9. And then the y-intercept is the number that we just found, the 32. Right, if I want to check my answer, there's a nice way to check my answer, which is come back to my 2 original points, put a 2 in for x. See that I got a 14 out for y. You can also put a 4 in for x, right? 9 times 4 is 36, so negative 36 plus 32 is negative 4. It works for both those points, so I'm pretty convinced that that really is the equation for my line. All right, take a look at the next one. The next one is 1, negative 16, and negative 2, negative 1. So I'm going to do the same thing. I'm going to first try to find the slope between the 2 points and then work on the equation for the line. Right, if I make a little rough sketch of 1, negative 16, way down here, and negative 2, negative 1 down here. So I'm looking for an equation of a line that connects those 2 points. Right, looks like the same type of slope as the one above it. In other words, it's negative. So I would expect a negative number when I calculate my slope. Right, let's line the other one up underneath the point that I have. So 1, negative 16, negative 2, negative 1. My slope is going to be change in y over change in x. So negative 16 minus a negative 1. There's my change in y. 1 minus a negative 2. So we got a couple of double negatives to be aware of here. Negative 16 plus 1 is negative 15. 1 minus a negative 2. 2 negatives make a plus. 1 plus 2 is 3, so negative 15 divided by 3 is negative 5. So, like we suspected, the slope is negative. All right. Then we'll take our y equals mx plus b and use either point to put in some numbers. So I'm running low on space, so I'm just going to call this x and call this y. Right. Negative 16 equals negative 5 times 1 plus b. So I take y equals mx plus b, y is negative 16. The slope I just found is negative 5. The x value is 1. So add 5 to both sides. Negative 16 plus 5 is negative 11, which makes sense, right? Here's our y-intercept. If that point over here has a y value of negative 16, then it makes sense that that intercept point is negative 11. So we come back over to the side. We're going to now write the equation for our line, y equals mx plus b. I need the y in my equation. I need the x in my equation. We know from up here, slope is negative 5. And we know from the value we just solved for, y-intercept is negative 11. All right, we can check our answer by putting in values for x and y that came from the problem and see if we really get a solution. All right, the third one looks like a couple of sets of fractions, 2 4/3 and 2/3 2/3. I'm going to switch over to a screen that gives me a little bit more writing space and copy down my 2 points. All right. My 2 points are 2 4/3 and 2/3 2/3. So let's work the problem out over here because it'll give us a little bit more space. All right, so just like before, the first thing we need to find is the slope. Slope is change in y over change in x. So my slope is going to be 4/3 minus 2/3. That's my change in y. My change in x is 2 minus 2/3. All right, first thing I might want to do is find a common denominator. So that 2 is the same thing as 6/3. Right? 6/3 is the same thing as 2, except when I call it 6/3, now I can subtract it easily. So 4/3 minus 2/3 is 2/3. 6/3 minus 2/3 is 4/3. If I were to plot these couple of points, over 2 up 4/3 might be here, over 2/3 up 2/3 might be there. I got a line with a positive slope this time. All right, so what's 2/3 over 4/3? Well, here, let's multiply top and bottom by 3. I can do that because if I multiply top and bottom of the fraction by the same thing, then it doesn't change the value. 3 over 3 is the same thing as 1. So you notice what happens. Up on the top, I just get 2. Down the bottom, I get 4. And that simplifies. 2 over 4 is a half. So that's my slope. Up 1 to the right 2. Now I need the equation for my line. Start off with y equals mx plus b. My goal is to solve for b. So I put in a 4/3 for y. I'm going to use this point up here. So I'll put in a 4/3 for y. I'll put in a 1/2 for m. I'll put in a 2 for my x plus b. Look how nicely this works out. I get 4/3 equals 1 plus b, and then subtract a 1 from both sides. 1 is the same thing as 3/3, so when I subtract the 1 from the left side, I'm going to think of it as 3/3. 4/3 minus 3/3 is 1/3. So my y-intercept is 1/3. All right, so we resize the screen a little bit. We come back up to the top. We're going to start with y equals mx plus b. And now we're going to fill in our blanks. We want to keep the y and keep the x. We'll put in the 1/2 for the m. And then we'll put in the 1/3 for the b. We can check our answers by putting in the x and y values and seeing that they work. A little bit more challenging because they're fractions. But let's try it for the 2/3 one, right? 1/2 times 2/3 plus 1/3 should give us 2/3. And sure enough, 1/3 plus 1/3 gives us 2/3. So we put in the x value, we got out the y value. All right, how about this one? In this case, we're given drawings of the graphs, and we have to write the equation for the line. So how does this work? Actually, this works nicely because we're given the y-intercept in both cases, and it's a nice number. It doesn't look like it's a 17/13 or something like that. They look like they sit nicely on the x and the y-axis. All right, so take a look at the first one. The y-intercept is -2. I can read that off of the graph. But what is the slope? Well, if I go up 1 and to the right 1, it doesn't land on a nice coordinate point. What if I go up 2 and to the right 1? I'm going to go up 2 and to the right 1, and look at that. I landed a point right on the graph. Try it again. Go up 2 and to the right 1, and I landed a point on the graph. So it looks like going up 2 and right 1 is my slope. Well, remember, slope is change in y over change in x. So I'm going 2 in the positive y direction, 1 in the positive x direction. My slope is 2. So my slope is 2. My y-intercept is -2. And so if I use y equals mx plus b, y equals 2x minus 2. All right, if you want to try the next one on your own, you might want to pause the video, try solving the next one, and then pick it up, and I'll solve it when you're done. All right, so now try this one. This one has a y-intercept of 3, and I need to find my slope. Well, if I go down 1 over 1, that doesn't hit the line. If I go down 1 over 1 again, it doesn't hit the line. What if I go down 2 and over 1? No. If I go down 2 and over 3, look where I am, right on the line. So it looks like down 2, right 3 is the slope of my line. So I'm going 2 in the negative y direction, 3 in the positive x direction. By the way, I can flip that. I can go up 2 and left 3, and I'll bet you that still works. I go up 2, left 3. Sure enough, there I am. So either way, the slope is -2/3. Y-intercept is 3. Y equals mx plus b. And then I replace the m with the -2/3 and the b with 3. There's the equation for my line with that slope and y-intercept. All right, let's try 2 more. These are easy. Vertical and horizontal lines, those are our special cases. Remember that a horizontal line has a slope of 0. And so all we have to worry about is the y-intercept. We can count. 1, 2, 3, 4, 5. Y-intercept is 5. Y equals 5, equation for my line. All right, the second one is a vertical line. Vertical line has a slope that's undefined. So I actually can't even use y equals mx plus b to calculate it. Technically, I could for the first one, right? I could say y equals 0x plus 5, which would have just given me y equals 5. But in the second one, I can't even use y equals mx plus b because the slope is undefined. That's all right. We know a vertical line is going to be x equals some number. What number? -1, -2, -3. All right, so every x coordinate on that line is -3. Y value doesn't matter. Whatever y value you put in there, your x value is -3. All right, last little bit in this section, writing equations for parallel and perpendicular lines. 2 lines that are parallel have the same slope. So if you think of lines going up and over by the same amount, they'll never intersect each other. It's like 2 people that are running and they're running at the same speed. They're never going to catch up. I mean, unless one person eventually stops. But as you're running, if they're running at the same speed, they're never going to catch up. All right, if 2 lines are perpendicular, the slopes are opposite reciprocals of each other. So first thing, perpendicular means intersecting at a 90-degree angle. Opposite reciprocal, that means change the sign. That means flip the fraction. So for example, 2/3 and -3/2 are opposite reciprocals because I flip the fraction and change the sign. What do I do if I have -2? Well, the opposite reciprocal of -2 is +1/2. 2 really means 2 over 1. Flip the fraction, change the sign. Okay, so those are opposite reciprocals. Slopes of perpendicular lines are opposite reciprocals. So the first question asks us to find the equation of the line that passes through this point, -6, -2, and is parallel to y equals -1/3 x plus 7. So if this is the slope of the line, this is also the slope of the parallel line. Remember we said parallel lines have the same slope. So if 2 lines are parallel, their slopes are the same. So I know right away that the slope is -1/3. What I need to do is I need to find the y-intercept. So let's use the same idea as before. We'll start with y equals mx plus b. We'll replace the y value with -2, right, because this is x and y. So y is negative 2. My slope is negative 1/3. The x-coordinate is negative 6. And I'm trying to solve for b. Okay, let's do a little simplifying. We got a lot of negative signs here. Negative 1/3 times negative 6 is positive 2. Right? I get negative 1 times negative 6 is 6. 6 over 3 is 2. All right, let's subtract the 2 from both sides. Negative 2 minus 2 more is negative 4. So when I write the equation for my line, y equals negative 1/3 x minus 4. All right, if you want to try and make sure it really does go through negative 6, negative 2, try it. You'll get 2 minus 4, which really is negative 2. All right, this second one, last example for this section, passes through that point, negative 4, 3. This one's perpendicular to y equals 2x minus 4. So if this is the slope of the one line, I want the slope of a line that's perpendicular to that. So we said opposite reciprocal. So my original slope was 2, right? Really 2 over 1, which means that the perpendicular slope, that's the symbol for perpendicular, perpendicular slope should be negative 1/2. Flip the fraction, change the sign. Next thing I need is the y-intercept. So if that's x and that's y, y equals mx plus b. So 3 equals negative 1/2 times negative 4. I'm getting that from my point, negative 4, 3, plus b. Negative 1/2 times negative 4 is 2. Right? Negative 1 times negative 4 is 4. 4 divided by 2 is 2. Right? And then subtract the 2 from both sides. 3 minus 2 is 1. Right? Last step, write our final equation. Y equals mx plus b. So we said the slope was negative 1/2. Y-intercept is 1. Right, we could try putting our numbers in just to check our work. Negative 1/2 times negative 4 plus 1. So that gives me 2 plus 1. And sure enough, I get 3. And that's what I was expecting. Right, and that's the end of this section. The next one, we'll take a look at how to find equations for lines using a different formula that we call point-slope form.